Hey guys, welcome to my channel Subhas classes. Today we are going for another chapter for class 12 and this is 3-dimensional geometry, one of the toughest chapters as you feel, but let us make it an easier concept which can be made much easier to solve, and this chapter itself is nothing but a practical experience with the things around us. Whenever you look at a distant tree, you have some angle of elevation. Whenever you look at the aeroplane or a duck swimming in the lake or in the pool, then you also have some depressions. So elevations and depressions make those problems of height and distance in trigonometry. But whenever you have something tied to a corner of a room, suppose you have a corner which you can term as x axis, y axis and z axis. The meeting ground of the three axes is the origin O. Suppose there is a person with a long nose like this, and you have put a string here and you have nailed it and just joined this line. See what will happen to the string when the person is there, and let us make it straight. You can clearly see that the string makes an angle with y axis, it also makes an angle with z axis and also with the negative x axis, or it also makes an angle with the positive x axis. If this angle is alpha, this angle is beta and this angle is gamma, what about the position of this point? Let this point be a point P with coordinates x, y, z. Then this point is at a height of z, at a width of y, and in the front back axis x axis it is at a distance x. So if we drop a perpendicular on y axis, what you find, this angle is beta and this length is y. So if this length is r, then we find cos beta is y upon r, base by hypotenuse. And if similarly, let us extend the z axis a bit more and let us draw it perpendicular here. The same string with length r makes an angle gamma here, and since this length is the same as z, so you will find cos gamma is equal to z by r. So clearly from intuition we say cos alpha will be x by r, because alpha is the angle with x axis. And these three cosines which are taken in a smaller form as L, M and N, these three values written as L, M, N are known as DCs or direction cosines. Direction cosines DCS, so we write them DCs. This is direction cosine. So what is direction cosine? What are direction cosines? LMN are those values which are the cosine values of the angles alpha, beta and gamma. The angles are subtended by a string or a length or a straight line with each coordinate axis. If a line makes an angle alpha with x axis, beta with y axis and gamma with z axis, then the cos alpha, cos beta, cos gamma will be those three cosines which are called direction cosines, because they show the direction of the point at an angle beta with y axis, with gamma with z axis and alpha with x axis. That point is located. So in order to find the location of this point, we can use alpha, beta, gamma, or indirectly cosine, cos alpha, cos beta, cos gamma, or LMN to find the direction. So a line can be written as having length r and having direction cosines L, M, N. We write it like this. And what about the ratios? These two are not always the same. Suppose this value is 1 upon 2. Suppose this value is root 3 by 2 and this value is 0. Then you see L is 1 by 2, M is root 3 by 2 and N is 0. Then what do we get when we find L is to M is to N? What will be L is to M is to N? It will be 1 by 2 upon root 3 by 2 upon 0, multiply 2 to all, 2 to each. So you get 1 is to root 3 is to 0. These are three different numbers other than these three, and these values are found from the ratio of these three. So since we get these three values as the ratio of the direction cosines, they are called direction ratios. And likewise, as they were called DCs, these are called DRs, direction ratios. So direction ratios, and they are termed A, B, C. They are designated as ABC. ABC and LMN are the proportional values. So we can say L upon N, L is to M is to N is A is to B is to C, or simply L by A is equal to M by B is equal to N by C. And using this relation, what are the things we get? Let us find. One expression is L square plus M square plus N square is equal to 1. Let us prove it. LHS is equal to L square plus M square plus N square. Since these are DCs, we can write them as cos square alpha plus cos square beta plus cos square gamma. Since cos alpha is x by r, this will be x square by r square plus y square by r square plus z square by r square, which will be x square plus y square plus z square by r square. And in a three-dimensional plane, these are, as you know, is x square plus y square plus z square, and this will be r square by r square, so equal to 1. So we found L square plus M square plus N square is equal to 1. And here the values we took 1 by 2, root 3 by 2 and 0. Add them, add their squares and find what we are getting. L square plus M square plus N square. The values just I took will be 1 by 4 plus 3 by 4 plus 0, 1 plus 3 plus 0, 4 by 4 equal to 1. So the values I took were appropriate. That means if the sum of the three squares do not add up to 0, do not add up to 1, then they cannot be properly DCs or elements. So if L, M, N, one of the values is 1, what will be the other two values? Because already you have got 1 square 1, so the remaining two must be 0. So this is a set of values 1 0 0. Another set of values can be 1 here and 0 0 there. If M becomes 1, then L and N should be 0, or if these two are 0, the third must be 1. So these are the DCs, and can you guess whose DCs are they? This is for the x axis, this is for the y axis, and this is for the z axis. And these lines have the DCs 1 0 0, 0 1 0, 0 0 1. And since the ratios, the simplified ratios of the things will also be the same, so they can also be taken as A, B and C. So x axis has LMN and ABC equal to the same, that is 1 0 0. Similarly, y axis will have 0 1 0, z axis will have 0 0 1. And with this we have found the fundamental things to study three-dimensional geometry, and here we cover up to DCs, DRs, their correlations like L upon A is equal to M upon B is equal to N upon C, and we have already found L square plus M square plus N square is equal to 1. If we just extend it, you can find L square by A square is equal to M square by M square by B square is equal to N square by C square, and from ratio and proportion chapter we have found that this can also be equal to L square plus M square plus N square by A square plus B square plus C square. If we know that L square plus M square plus N square is equal to 1, and if we take this as a square of a certain value lambda, then what we get? Let us take the square roots again. So we will get back L by A is equal to M by B is equal to N by C, and finally here 1 by plus minus lambda, so that we get L is equal to A by plus minus lambda, M is equal to B by plus minus lambda, and N is equal to C by plus minus lambda, where lambda is equal to root over of A square plus B square plus C square. And this is all about the part 1 of three-dimensional geometry. Have a practice over this, and so that you will be ready for the next class, and in the next class we shall apply all these things to solve the first exercise of the three-dimensional geometry chapter. Till then, have a view and comment whatever you need to understand this chapter, and in the till the following class, let us have an end here, and thank you for watching this video. Bye.